Thank you. All right, thank you all for coming, and I appreciate B-Sides Augusta for bringing me out here. I started my journey in Red Team proximal to B-Sides Augusta several years ago, and I gave my first talk here on transitioning from pen testing to Red Team, and I was also very grateful to give that talk here. So this presentation presumes you have a Red Team already, big or small, and it doesn't explain how to start a Red Team. I must say, though, that the only wrong way to do Red Team is to ignore the needs of your Blue Team. Now, we are 7 engineers and 1 manager. We have grown and changed in size and shape over the years. We've been reorganized and shuffled. And we all have various backgrounds and levels of experience. We work alongside our Blue Team, and we encourage both casual and formal collaborations. We even eat lunch together. And every day, we share cool stuff with cool people who are engaged and challenge us and make us want to make each other better. Now, we support and are supported by our incident responders, our detection engineers, our security engineers, even our leadership. And we're also supported by our internal business teams. So we collaborate with product owners and business teams to understand how they get work done and how to improve their defenses against threat actors. Now, we're distinct in function from our penetration testing and vulnerability management teams. Combined, they are both 4 times as large as we are. And their stellar performance prevents us as a Red Team from having to spend a lot of time hunting for and reporting on vulnerabilities. This also allows us to focus on detection, response, and threat actor emulation. So our environment spans some 1,900 physical locations, and this allows for ample opportunity for drift and variation and failure in the environment. Our security technologies and some 1,000 manually maintained rules to support those technologies are spread all across the enterprise. Their functions are maintained by a variety of teams, including vendors and IT teams like desktop engineering. One team may install a technology, another may maintain it, and yet another may make sure that it's actually running. So the equal distribution and effectiveness of all of these technologies has to be reasonably assured, right? Our Red Team is a major driver of that goal. Sorry, I'm rushing through this a little bit. I'll give you some breaks, but I want to make sure that we get in time here. So in service to this, our Red Team gathers information from inside the organization in order to best prioritize the playbooks that we're going to use for attacking the environment. The business deploys new technology at an astonishing pace, so we're constantly learning about those things. We combine that with data collected by our extremely capable threat intelligence team. And again, we'll use that to pick and choose which techniques and behaviors we want to exhibit on our Red Team operations. Japanese macaque break. Like many other Red Teams, we were doing a handful of long-term operations a year. However, we found that there's a finite amount of data that we can extract from individual operations. For example, the affected hosts or the number of techniques that we use. What was kind of surprising was that even the individual analysts assigned to the response for those operations had slightly different approaches to their work. We found that the greatest variability comes from the incident response process itself rather than from the environment. You'd think that in a very large, constantly changing network, those things would be the king of the unknown, the environment itself. It's Wild West, but alas, the response process actually provides us the most opportunity for improvement. So we came to the conclusion that if we want to maximize the amount of novel information our Red Team can create, we'll run shorter, more frequent exercises. We also acknowledge that short operations have a few disadvantages. Among them, some threats may persist for months inside of the network before discovery. Adversary actions can become complex and have a large blast radius. Accurately simulating those threats is difficult without adequate time. So in order to achieve an ambitious goal like 100 red team operations a year, we first organized 2 weekly operations a year. These had similar structure, such that every step of an attack was covered in both cases. But the key difference was that one operation always completed with a technique that matched a detection rule. Yes, this means that operation would always intentionally fire an alert. Now, I hear you screaming colors at me, and that's just fine. Just sit back and relax. We'll get through this. What this allowed us to do is to scope certain operations almost entirely around the response process. We can then scrutinize the incident response process rather than add compounding factors around detection and visibility in the environment. The second weekly operation was more typical of other red teams, done mostly within visibility or detection gaps in order to achieve specific goals. We sought to answer questions like, are all existing rules generating the expected alerts from endpoints at all network locations? In order to do this, we had to add a third weekly test, a hands-on QA test, and that at 3 projects a week. That's starting to add up now. And so this meant that we were on the hook for manually doing about 150 reportable exercises per year. And that number, even now, is exhausting just to say. So how'd we go about this? Beginning each operation with an earnest attempt at initial access, we will have expended a lot of time and energy on a small selection of attacker techniques. Consider this list of technique categories. This is from the MITRE attack framework. The value of our operations is primarily in techniques that occur after initial access. Right? This is where our most impactful improvements can occur. Given that understanding, our most frequent operations are executed with the assistance of volunteers from inside our business. Those volunteers usually help us in executing a social engineering attack. We on the red team will create a scenario, like an email, and that volunteer will be asked to do what people are so good at doing, opening emails. This work is also commonly done on checkout hardware, which is lent out to the volunteers specifically for testing purposes. And since our red team operations are so frequently responded to, the hosts and accounts scoped into those operations are sometimes disrupted by the incident response process. So we're having to be cautious about how frequently we interact with production assets and productive people, which is also something that's just as important as production assets. However, for us, only a modest percentage of the hundreds of operations we've done have had some business impact. And those impacts are almost entirely in end user productivity. An example, this would be like if we were resetting the password on a user's Active Directory account. So we've essentially traded some demonstrations of high-risk techniques in sensitive production environments for far more frequent demonstrations of low and medium-risk techniques in production-like environments. We get additional benefits in engaging more directly with people within our business and doing so in a positive way where we invite them into the process, bringing awareness of what Red Team does outside of the security organization. Snowfox break. So taking an ad hoc approach to development and infrastructure was really holding us back. It was taking several days to prepare the components necessary to run an operation, which meant that a weekly test was running out well beyond the test week itself. And with multiple concurrent operations, a setup where a few servers that live forever but get constantly changed and repurposed over time was preventing us from scaling. So we changed our approach to infrastructure by doing a complete tear out. We built from the ground up a brand new cloud environment where computing resources were automatically deployed as needed for specific operations and then destroyed after their completion. And this this deployment process takes minutes for us. This was achieved using a combination of infrastructure and configuration automation, deployed from code repositories, and configured with a very small text file. While we have a single master branch for everything, all of our team members can deploy their own branches or make changes before or after deployment in the environment. Now, what we've managed to do with this is drive down the busy work streamline tool development, and let our operators focus on executing techniques, which is at what the core of our red team does in operations. So, if you've picked up what I'm laying down, we do DevOps on red team, and I would suggest that all red teams do DevOps in one way or another. If you manage your code and tightly knit it with the underlying infrastructure, you're pretty much doing DevOps. So let's think about that methodology for a little bit. We're also planning our development out as best we can. We're tracking everything in issues, using project management tools, but the security of our environment is actually the very first priority for us. And since security entirely builds around automated configuration, we can worry less about errors made by operators. Now, this all may sound like a lot of overhead, but be sure that we're very conscious of how much time we spend making our tools. And now, if I write a piece of code, I have to make sure that someone who's never seen it before can run it safely during an operation. And if they choose to, make changes and commit those changes back to the repository. This means everything has to be very well documented. Now, with this process, what we've managed to do is to make tool making sustainable for our red team. Now, maintaining detection awareness has been pretty challenging for us. There are dozens of distinct technologies in the environment that our red team has to keep track of where detection and prevention reside. And so as an organization, we don't even own some of these technologies. It may be hard or impossible to query a rule set that exists in a particular technology for that very reason. But whatever can be made available to red team has been made available. We operate with complete technology transparency. And let me emphasize, this saves us so much time. It also gives us opportunities to spot problems that thousands of red team operations may never reveal. Our blue team has built out a tool which catalogs all of the rules in our environment, along with metadata about when they were created, where they live, and what intelligence they were based on. Now, we use this and several other tools to pick our techniques while planning operations. Our red team can reach into these tools, do a search on a keyword, and find out most of what we need about how we as an organization can detect a particular technique. Now, our red team and our blue team also share the same physical space, and that allows for casual collaboration for us. We share a chat room, specifically for red-blue collaboration, where we can talk about detection techniques. Since we do this so frequently, we've had to keep our reporting requirements to the bare minimum. And what we do is with each weekly operation, we create a very concise wiki entry. When the reports are completed, we'll package them up into an email, just copy paste, and then we'll send that out to actually a fairly large list of security team members so that they can all be aware of what red team is up to. Now, for our long-term operations, they may get a longer report, but for the purposes of the majority of our operations, we spend maybe 20 minutes working on our reporting. So this is the template that we use for weekly operations. At the top is a short summary of the operation and its objectives. And we identify the subjects of testing. And we also know what role or access within the organization that they have. And that's in order to help us put the risk in perspective for other people in the organization. So we'll document details about the delivery mechanism and put a timestamp on everything, of course. This includes when the compromised activity begins and when it ends. If there's exfiltration performed, we'll identify what that data was, where it was staged, and how much. We'll document specific IOCs, host names, addresses, email addresses, hashes, URLs, that type of thing. And to tie our operational work to actual real-world threat actors, we'll list out how each attributable technique is related to an in-the-wild threat actor. And this will include a link to either public or internal documentation on that threat actor or technique. We'll enumerate any alerts that may have fired or should have fired, I might say. And then, of course, we link that directly to the case number in our case management system. This may seem light on the details, but keep in mind that we also keep logs for all of our red team tooling, right? So if we need to go back and look at a command or a process, we can dig back into the database and pull that information out, if necessary during a debrief or if somebody has specific questions. So with a high volume of operations, the opportunity for unnecessary escalations increases pretty dramatically. When an operation begins, what we do is we tell a selection of partners within the blue team what the time frame of the operation is and who the intended targets are. There's an agreement to keep these data points secret from the people who actually respond to cases. And what that allows us to do is let red team operations run their course, but allow the right people to de-escalate if necessary. Bird and snow break. Okay, so eventually the grind of running this many operations, 3 per week, is with only a handful of engineers, was really getting the best of everyone. Not only the red team, but also our detection engineers, our incident responders. Everyone was overwhelmed, basically underwater with the amount of information we were gathering. So our long-term operations were also suffering from lack of resources. And we weren't getting good value out of that manual QA test that we came up with. Our ambitious plan to conquer improvement through brute force basically looked like this. Though perhaps we might take what we've learned doing 2 labor-intensive operations a week and a 3rd QA test and incorporate them into a more balanced schedule. To approach this, we now separate operations by time span, as well as define different objectives for each of them. We take some of that work that we were doing through manual QA testing and we automate it. For us, long-term operations are strategically focused, looking for gaps in process, policy, or design. Medium-term operations are centered around detection engineering and hunt capability, and also working with individual business teams. We now run 2 of these medium-term operations a month. Short-term operations primarily exercise our response capability and do some quality control on detection engineering. We cut those down to once a week. So now that we have wide coverage of different organizational goals, we can maintain high quality and quantity of results with a schedule that looks a little bit more like this. Everyone can kind of take a breath. Now with automated QA testing, we can monitor the effectiveness of detection and prevention technologies within the organization without the red team being the first to find out about it. Our red team partners with other security engineers to develop this capability, and we're hopeful that we'll be able to run hundreds of tests daily that assure that there's no human interaction required to make sure that when things fail or things drift in the environment, we'll be notified automatically about it. Now, not only can we provide high-quality, intelligence-backed red team operations, but a red team is not burdened with continuously monitoring for drift or failure in the existing controls. Now, a team we call continuous improvement is dedicated to security measurement and accountability. This team tracks security performance across multiple groups and is the primary facilitator in the red-blue relationship. After each operation, the data that both red team and blue team generate are compiled in an after-action report. And because this report is generated by a third party, we have the benefit of a more objective viewpoint. Then that report is reviewed in a meeting with members from all of our partner teams, the debrief, and there's usually 20 or so people in the room when this happens. The entire timeline of the operation will be reviewed and reassembled, and everyone in the room in those debriefs will look for opportunities to improve. Continuous improvement also sifts through and reports on large amounts of security data. For example, here's an analysis of 4 years' worth of our case information. This chart illustrates how the weekly volume of malicious cases correlates to the average time it took to contain those threats. What this is suggesting here is that there's no direct correlation between those two things, right? Where we see that if the case volume increases, our contain time remains fairly consistent. So if the dependent factors here are yet unknown and require further investigation. Continuous improvement also regularly meets with our management to discuss overall security performance. And red team backed data, this very data is a strong contributor to those discussions. Now, we've found only a few ways to quantify red team's performance. And the most important to us seems to be the number of red team generated action items. We estimate as long as red team is identifying areas for improvement and those findings are being addressed, we are hitting our performance benchmarks. One of the metrics continuous improvement tracks is where each action item lands in terms of how the action might be addressed. Now, this is a breakdown over a 4-month period of all the action items our red team generated. We can see that visibility is a tiny slice there. Some time ago, that visibility slice might have represented a larger cross-section. However, as our red team has spent time operating in the visibility area, those gaps were greatly reduced. So we're making sure that our red team is addressing the areas most in need of improvement. We can also examine red team performance using our containment time metrics. So this is data for an entire year, and we can see that containing our red team often takes longer than the average malicious case. But we can also see that we're rarely too far ahead for too long. Tracking this data helps red team tune its operations to match the blue team's capability. We are maturing alongside the blue team, not running far out ahead, where the dragons of diminishing returns live. Another way to measure red team is frequency of operations meeting established goals. There's rarely a shortfall for us here because our goals are fairly straightforward and rarely all or nothing. Allowing for graceful failure is one of the ways we maintain a positive working environment for red team and assure that weeks or months worth of work rarely goes to waste because of a single mistake. If we can provide some consistent operational data, performance measurement is easier. If something somewhere was learned by someone, we'll consider that a success. But if not, as we say on red team, there's always next week. Another way to gauge our red team performance is how much mentoring, training, and professional development happens. As long as our red team is continuously learning and passing that knowledge on to other teams and junior team members, we will remain high performing. So in service to this, our red team does direct training. We know that if our partners understand how we do business as a red team, they're more capable of communicating their needs, helping us meet ours. We present on various topics like reverse engineering and malware development to large groups. We do debriefs directly with analysts who have expressed that one-on-one time with our red team is important to them because they get the opportunity to ask questions in a safe environment. Now, our team, like others in the security organization, operates a shadowing program. Members from other teams are spending a few days working alongside our red team and getting some whiteboard theory on how we work. As well, our red team shadows other teams, giving us the opportunity to see a much better understanding of how the rest of the organization as a whole functions. This process allows us to be more empathetic about how we do our work and how we can get the best value for every hour of every day that we put into it. So, sounds kind of like Agile, doesn't it? Weekly sprints, monthly sprints, quarterly sprints. But we've also become a proper software engineering team, capable of planning, developing, delivering stable products. We deliver services based on those products. We're tightly integrated with other security teams with great working relationships. We're capable of measuring what we do and using that to improve week over week. We can do really cool things and do them quickly. It's been years, but we're still at this process. We've done it with as few as 4 engineers. We've done it with much better with a team twice that size. And since we've become more strategic about what, when, and how we do our operations, we're all happier and have drastically reduced the amount of work required to do quality operations. Now, like I said in the beginning, there's no one right way to do red team. I just hope that our story will inspire you to try new things that, for us, have driven meaningful change. Thank you. Got things to give away. Somebody name one of the animals that I displayed. One more time? All right, got you. Arctic fox, there we go. You got him?